Okay, this is GCSE Further Mechanics. We've just started the equations of motion, so we're going to be using those then to solve some of these problems. A cyclist starts from rest and accelerates at 0.5 meters per second squared. How long does it take him to cycle 100 meters? And what is his speed? Obviously meaning then at that time. So the way I tackle all of these is to write out U, V, A, S and T to start with, and fill in what I know. A cyclist starts from rest. That means at the start the initial velocity is 0. Acceleration is 0.5. How long does it take him to cycle 100 meters? That means our displacement is 100 meters, and they want to know how long does it take. So that means we've got to work out T. And it means that we've got to work out then a speed at that time, which is going to be V. So we have U, A and S, and we want T. This isn't always the best one to use, but we're going to use S equals UT plus a half AT squared. That means 100 equals 0 times T plus a half upon 0.5 T squared. 100, that obviously goes to 0, half upon that is going to be a quarter T squared. Times both sides by 4, we would get 400 equals T squared, and that gives us then T is 20 seconds. We don't take the negative, obviously you can get plus and minus 20 out of that, but minus 20 seconds wouldn't make too much sense in this scenario. So we have our time. We're now going to use U, A and S to work out V. Of course you can use a T there in there, and if you've no other option, it certainly sometimes makes your life easier to use it, but we're going to use V squared equals U squared plus 2AS, means we're not using any new information. So V squared equals U squared plus 2AS. V squared equals 0 squared plus 2 upon 0.5 upon 100. V squared 2 times a half is just 1 times 100. So we have that, and our V is plus or minus 10 meters per second. Therefore our speed is 10 meters per second. Incidentally, if it's deceleration, just as wee bits added in here, just maybe kind of for the next question, so if acceleration is minus 5, this is a deceleration is 5. It doesn't help in this particular question, but just for future reference.